My name is Kory. I'm the Chief Technologist, and I'm going to be talking about the iRODS HTTP API we've been working on. All right, so here's a slide showing what is going to be covered in this talk. Clearly, we have several things, and we have a little bit of time to cover all these things, so we're just going to jump right into it. First off is, what exactly is the HTTP API? This is an experimental redesign of the iRODS C++ REST API that was introduced a few years ago. It pretty much has the same goals as before. We want to provide a consistent, cohesive interface to iRODS that's simple for developers to write iRODS-specific software. We also want to try and maintain performance close to iCommands. And a big one here is that we want to remove differences between client-side libraries such as Jargon, the Python iRODS client. We want all of these programming languages to be able to access the iRODS server and produce the exact same behavior across languages. And last but not least, if everything goes well and people adopt it, then we are looking to have this absorbed into the iRODS server, possibly. This is actually one of the things that is actually recorded in the iRODS roadmap. And so this is the first attempt at doing this. So you might be wondering why this is necessary if we already have the REST API. Well, we already know that the REST API proves that we can do this, that we can present iRODS over HTTP. But as people have used the project over time, they've uncovered and reported some challenges. The development team has also encountered some challenges with the project, and that one thing is that the community has reported concerns around the number of ports needed. There's also some stability issues that are we're not quite sure what causes those, but it results in sometimes processes crashing. There's also the implementation presents some complexity, and so we especially noticed that with some of the interns who had to work on this project, that they encountered some experiences around difficulty in introducing new functionality in the project. A big thing here is that the Pistache HTTP library that this is built upon lacks completeness and maturity and adoption. There's some libraries such as Draughn, which are really extremely popular, and people tend to favor those. And so we want to move away from Pistache and use something that we know is going to be maintained into the future. There was also some issues around like naming because of the REST API design. This made it a challenge to add additional functionality that makes the interface cohesive. And so this project is our attempt at resolving all of those issues. And if you want to know if you want to see what the original document is that led to this project and this effort, you can click the link here at the bottom. All right, so some early design decisions that we made up front is that we want to move to a single binary. This is very easy for people to hold and not get confused about things. This would also mean that we want to move to dealing with just one, maybe two ports. Another decision that we made in regards to Pistache is that we moved from that to Boost Beast because iRODS already ships Boost as an externals package. And so Boost Beast is a mature library that's provided by Boost that allows us to write high performance HTTP client applications and servers. We also wanted to simplify the interface a bit by introducing a fixed set of URLs so that it's easy for administrators and users and developers to remember. And last but not least, we replaced the use of REST with HTTP because REST feels very strict in its design ideas. And so instead of trying to follow those design principles, we decided let's just focus on designing an interface that makes sense to people, and is very easy to understand. So the first thing here that we're going to talk about is API URL. So here, all of these endpoints are based on concepts and entities defined in the iRODS ecosystem. For example, /collections, data objects, metadata, these are all things people are familiar with. And so The idea is that if you want to know something about, if you want to manipulate something like tickets, then just go look at the tickets the tickets endpoint. There's no additional nesting necessary, and this just keeps everything simple. There's no additional URLs to learn, and this is just kind of like the approach that we're taking to make it easy for developers to get on board and just do the things that they want to do. Next up is API parameters. So with every endpoint, except the authentication endpoint, all of these accept an op parameter. This is just a short name for operation. This is how we expose any number of operations supported by an endpoint, such as stat, list, create, remove. The list goes on. We can, if we wanted to introduce new features, then we can just add a new op value, and just map a function to it. This makes everything simple. This makes it also easy for interns and people looking to contribute to the project to just jump in and kind of just read the code and know exactly how things flow. Throughout the interface, you will notice that there's some common parameter names used throughout, such as LPath. This is just a short name for logical path. There's replica number, source resource, offset count. None of these parameter names are final. They may change in the future. With that said, we can talk about the configuration. At the highest level, we define two sections called HTTP server and iRODS client. This is modeled after NFS RODS. The HTTP server section defines all of the front end, the side for people that's going to communicate via HTTP. And then the iRODS client section defines iRODS specific connection information and other properties. And it's defined this way because we believe that this is easy for people to understand and reason about. So here's a complete example of all the properties that you can define that are available through the HTTP server section at this time. Obviously, you can define things such as the host and the port to accept connections on. There's the log level property. There's an authentication section so that you can add properties about basic authentication or OpenID Connect, whatever. The request section defines things like the number of threads that are dedicated to accepting new connections, as well as buffer sizes and timeout settings. And background IO is specifically, it only has threads at the moment, which is basically a dedicated, this basically defines the number of threads dedicated to handling long-running background tasks, such as these would be things such as iRODS specific operations, such as writing bytes down into a data object. The background IO threads are primarily there to keep the foreground threads from being blocked from accepting new connections. Here we have the iRODS client section. This is where we define iRODS specific properties. Some of these should be familiar, such as zone. An important one here is proxy RODS admin. This is the admin account, which is used to proxy all connections. We have the connection pool where you can specify size of how many connections should be available to the server, as well as refresh times. There's buffer options or buffer size properties as well, and also there's a max number of rows per catalog query. That is just a default. The next thing here we're going to talk about is connection pooling. This is very important. So normally what you see with iRODS applications is a lot of clients love to connect and disconnect frequently. This kills performance. And so we set out to try and fix that with 4.3.1 by first providing the RC Switch User API plugin, which allows you to reuse connections. You can go and look at the PR to read all about it. We also make some enhancements to the iRODS connection pool and client connection libraries, which that work has not been merged, but we've added support for allowing people to construct these objects as proxy users. And so with these facilities, we're able to get a lot of performance out of the HTTP API. So this is a block of C++ code. I don't expect anybody to read this, but essentially the idea is that this pulls a connection from the connection pool, and then it invokes RC switch user, which allows you to, which changes the user associated with that connection, and this just boosts performance, by a number of by a large amount. So with that, that's one way that we gain some performance back, but now we're going to talk about parallel writes, which is a feature that was not provided by the C++ REST API at the time. And so this slide here simply details how you would go about setting up parallel transfer over port 1247 in iRODS today. If you were using C++ or C, this is what Python and Jargon both do underneath the covers. It's a bit easier to do with those libraries, but we want to take it a step further and make it even simpler. Okay. The way we do that is by introducing the idea of a parallel write handle. This is essentially a handle to internal state that's maintained within the iRODS HTTP API. It essentially maintains dedicated connections to uploads, and this is controlled through the use of two operations called parallel write init and parallel write shutdown. So parallel write init essentially is responsible for allocating a specific chunk of memory for the upload process, and parallel write shutdown is responsible for tearing all this stuff down in the correct order so that you don't have to worry about this on the client side. There are some strict rules around the header, the HTTP headers and things, and how you have to invoke this API in order to make all this work. Here we have an example showing all of the steps of how you might, well, it just demonstrates how you would do on parallel writes using the HTTP API. In this example, we're going to use curl to open up 3 streams to a data object, and we're just going to write 5 bytes. So we're not actually leveraging all of the streams, but the point, hopefully you get the point. So here we just define where's our HTTP API server. And here's our first instruction where we invoke parallel write init. We essentially give it the logical path, and we request a specific number of streams dedicated for this upload. And then we pipe the results from curl to JQ, and we extract the parallel write handle that's returned. This is later passed into the write operation, which can be used for synchronous writes or parallel writes. The optional parameter here is parallel write handle. In this example, this is what we use to inform it about the actual transfer handle that we just received from our last call. And this is where we also specify the number of bytes that we want to write along with the actual content. And what you'll notice here is that we didn't specify which stream to use. So we're leaving that decision up to the HTTP API server to determine. But we do provide an option called stream index, which allows you to pick and choose which stream you want to use for the upload. And our final step is we call parallel write shutdown to tear everything down and make sure that the catalog is updated in the proper way. Okay, so we did a performance test, a simple test. We wrote a Java application which uses the iRODS HTTP API. This test was done over from a home network, my home network, to the office network. And this was not an application that's highly optimized. This is just an example to see what kind of performance we're possibly looking at. And once you compare the performance to output, in the test we used 4 threads for each application, and we wanted to see how much time it took to upload a 100 megabyte file. Obviously, this is not the fastest speeds, but because we're dealing with the home network. But as you can see, the actual transfer speeds are relatively, they are almost identical. Obviously, the HTTP API, because there are buffers and things involved, it's very sensitive to the size of buffers and the number of threads that you dedicate to things. As for general performance, we ran another test We used Apache Bench to measure requests per second. In this test, we sent 2,000 requests total, and we maintained 500 concurrent requests at all times. This was all done using a single machine. This machine had 32 cores with 200 plus gigs of RAM. It obviously ran a custom build of iRODS because it needed the newer facilities, and the iRODS HTTP API was compiled with optimizations enabled, and we dedicated 32 threads to the foreground processing, and also we gave the background processing 32 threads. And these are the results that we got. We tested 3 endpoints. The authentication endpoint, using basic, AKA native authentication, we were able to get 133.2 requests per second. 50% of those requests took at least 3 seconds to complete. Then we tested the resources endpoint. All we did was stat a resource, and we got about 2,600 requests per second. Each request took about 167 milliseconds. And then for data objects, we wrote 8,000 bytes constantly, and we were able to maintain about 700 requests per second. I'm running a little bit low here on time. So here we just have some additional examples showing how you can perform a stat on a collection, and how you would call that and the kind of output you can expect to see. It includes all the basic information you're familiar with. Same thing here, we have this demonstrates how you can fetch the rule engine plugins that are installed on the connected server through the rules endpoint. So as for remaining work, we have several things that we need to consider and do. We need to write tests for this. All the testing around this has been done through manual testing. We need to improve performance around the authentication endpoint. Obviously, we want to add support for jQuery 2. We need to, produce documentation so that people can just immediately start consuming, making use of this, and as well as some of the other items here. As for future plans, we want to consider bringing in some of the features that were available to you in the C++ REST API, such as being able to disable endpoints. This was free with the REST API because it separated a lot of the functionality was distributed across multiple binaries. And so we want to consider bringing that back. The idea of enabling and disabling features. We also want to consider how best to support load balancers. So parallel writes are obviously stateful, so we got to think about how to deal with that. We also want to deal with long-running agents, which may contain stale information, because RC Switch user, the longer you have an agent running, if people are manipulating resource hierarchies and things, then long-running agents don't see those changes. And so we need to think about how to deal with that as well. And with that, thank you. Are there any questions?
Becomes a stable working API. If you're talking then about your future vision, like you said, does it then mean that after that time, for example, the Python iRODS clients or other clients will disappear or be discontinued?
I don't see those disappearing for a very long time, because in order to do that means that we're preparing to replace the existing XML protocol and the binary protocol, and that's just not going to happen anytime soon. This would sit alongside those as an alternative, and we hopefully see people migrate away from those interfaces to something that produces results that are identical across languages. But the choice would be up to you.
So with the RC switch user, it was called, how is in the iRODS rules, the like temp storage, or in Python rule language where you'd set something as a global variable, how are those preserved between, are they cleared when they switch user, or are they preserved somehow?
Honestly, so all of that state would be preserved today. I don't know how the API plugin would actually work with those. I don't see an issue because we are touching all of the state within the server side to make sure that this connection appears as if someone just created a brand new connection as that user. And so it's possible that we may have missed some steps, but in my testing, I have not experienced that.
Thank you.
So one of your slides where you showed some performance numbers, the authentication 50% took 3 seconds.
Hmm.
Is that, am I reading it right? Okay.
133 requests per second.
Okay. And the other thought I had is as you start offering these things, the denial of service becomes easier for a untrained user. Do you see introducing something to limit that kind of abuse?
I don't know if I quite understand the question.
So it's easy for somebody to do curl and HTTP and then write a snake make that says, go get me 5,000 things.
Yeah.
And suddenly we have a user hitting us 5,000 times with HTTP request. So that will become eventually a denial of service to other users.
Mhm.
So as we are introducing some sort of ease and access through these new capabilities, are you imagining ways to provide some level of control at the administrative level and say, you know, this authenticated user can only, or this IP address can only allow this much to come in. So that way the servers are not overwhelmed. And I'm saying this out of experience of what we witness in servers.
Yeah, so Boost Beast, the actual HTTP library that we use, offers offers features such as rate limiting. I know that that's not going to solve all the problems, but you know, this is still a early experiment, and so we are looking to we want to hand this to people and see what they find out, so that we can improve it and come up with solutions that work in a way that is, you know, maybe the solution is on Nginx or Apache HTTPD, right? Instead of it actually living inside of the HTTP API. I actually just don't know all the answers to that.
Yeah, yeah. I mean, we are happy to share everything that we have done with Nginx to limit these things, but to us that has become almost an essential layer,
Mhm.
or else you end up getting abused very quickly.
Definitely open to coming up with solutions that maybe ship with the HTTP API. That's certainly on the table for discussion.
Yeah, we've had at least the Nginx version in production for at least what 2 or 3 years now, Tony. No, the Nginx thing that you limit the number of HA proxy. Sorry, about 2 or 3 years. So yeah, so we're happy to share what works and what doesn't from what we have seen, and I think it'll be helpful for you to provide that as like a template, because if you just enable one of this, it'll start hurting the user or the administrator of the system, and eventually people get mad because they can't do their day job.
Okay. Yeah. So if there are, okay.
Okay, so you're talking about absorbing this into the server.
Yes.
So how is that going to affect the dynamic policy? Because as it's a standalone front end right now, all of the dynamic policy enforcement points are going to remain consistent.
That is a long-term goal that I have not thought about how to do, but it is something. I mean, certainly it's a thing that we are proposing, because this may replace the entire XML binary protocol one day.
Right, but that means everyone's policy implementations are now going to have to get touched again.
That's true, and that is something I think that we would look into providing perhaps mechanisms to assist in that kind of transition.
I was wondering about the switch user business, and I guess in past experience, like, is there value in taking a connection and switching the user over the fact that really what you're doing is you're sort of amortizing one user's login, and you're going to have a user probably make repeated interactions to the REST API? Whether, did you decide that was useful, or is it more simple to think about pulling connections by the user ID and just sort of segregating that activity? And also, are you running into issues with the statefulness? And I know there are some corners like with queries, like, to make sure that paging is limited and some of these various other things, so you don't get sort of gibberish answers from the agent, based on a pending operation, and how you think that maps to the sort of REST interaction style. Those are just a couple things I've run into in the past. But otherwise, this is super useful too. And I'm going to pretend it's done for the thing I want to talk about tomorrow.
All right. I think that's, I mean, if there's additional questions, please come see me, but if not, we're going to move on to the next talk.